4 to 5 years ago, I seen a need for, I call it mail order fabrication. What will happen is a customer will want a cooling system, say for an aircraft. After it's all figured out, size, shape, locations, and stuff like that, what they will do is they will send me a mock-up, and a mock-up will look like something like so. It's not very pretty, but it gets the message across. It has your locations of your inlets, your outlets for your water, for your mounts. It has provisions for your baffling, so you put your baffling on here to direct your air into the rad. Also, being that it's custom made, there's one of many fittings. I can put temperature sensing probes any place on the top tanks, bottom tanks. I can move this to the side, move it to the top, whatever you want, whatever suits your needs, whichever makes your application much more user-friendly. As a matter of fact, this is what the finished product looks like. There you got the front, you got the side, you got the back with the mounts and your inlet and outlet tubes that are beaded for your hoses, so when you slip your hoses on, you put your clamp on, hose is not going to slip off. What happens is these are the way I get the cores. I will get the cores, being that I'm building two radiators of the same size. This is what they call header to header or tank to tank from here. I can cut the core down this way, so I can make you a radiator this big or that big. This way I can cut it down this way, but I cannot cut it down this way. This is a locked inside size by the manufacturer, because what they do is they weld these tanks on, and they got a special process in which they weld it on. But what I say is when a customer gives me the specifications as far as the width is concerned, I can cut it down, cut that down, and then what I do is I bend my tanks, as you see the sample here. This all gets cleaned down. You got to clean all the welding flux out of here. This gets put on like so, and it will get welded, TIG welded here, and then there's end caps that get put on like so. This gets all welded around here and gets welded down here, and then I put the and this one here is going to be for a drain, so that will be a drain put in there like so. And then you have your other tank, which will, as you can see on the other sample, it's stepped out. That will be put on like that. And then, okay, these are a little longer than those ones over there, but that'll get machined out and welded in there, and that will be cut out and welded in there like so. And then on the side we have the mounts. There will be another plate of aluminum that will be a finish-off plate that will go on the side here and on the side here, just like we have over here, that you'll see this piece right here. And it serves two purposes. First of all, it finishes off the side of the rad, and also it's a mount flange for your ducting. And then off that will be welded your mounts, like approximately there. That's where the mock-up comes into play. It gives me all my specifications. Then what will happen is before I cut my inlets and outlet tubes in, I will drill this hole out. I will put my temperature probe in here, and what I do is before I proceed any further on it, I pressurize it. I have a test tank, a water test tank, and I pressurize it with double the pressure of the normal operations. If it operates, say, at 16, I'll pressure check it to 30, 35 pounds. This way it gives me a lot of leeway as far as strength is concerned. And what I'm looking at is, this is a very critical weld here because it's very, very thin. And this weld here has to be welded solid and leak-proof on both sides, on all four sides. If it's not, I have to take corrective measures to make sure it does not leak. And then once I've proven it out that it does not leak, then I can proceed with putting on my side caps, my mounts, and going on and putting in my inlets and outlet tubes.